Good afternoon, everyone. Welcome to the Construct Innovate webinar series on innovation entrepreneurship. My name is Jamie Goggins and I'm a co-director of Construct Innovate. Construct Innovate being Ireland's National Research Centre for Construction Technology and Innovation. This week, the focus is on disruptive innovation in the construction sector, and we're looking at what's on the horizon. This is the third week of the 7-week series on innovation entrepreneurship. And again, we're really fortunate of the quality of speakers that we have today. So we've got my co-director of Construct Innovate, Dr. Magdalena Hajdukiewicz, who's going to talk about transition pathways from construction. So all the way from what's driving this pathway from digitization and sustainability to produce a more productive sector for the benefit of society. We've got Pat Barry, who's the CEO of the Irish Green Building Council. And he's going to look at disruptive innovation and look at that we basically can't keep building the same ways we used to do in the past, from urban design to construction materials, because we have a climate action plan and we have to stay within our greenhouse gas limits in there. And then we have Roy Crielaard, who's a senior structural engineer from Arup, and he's going to talk about creating sustainable future-proof buildings and going to show some case studies that he's been working on in there. So we'll have our three presenters and then we'll follow by a Q&A session at the very end. So if you have any questions from any of our three speakers, please do pose them in the Q&A function at the bottom of the screen, and they will deal with all those at the end of the three presentations. So without further ado, I'm going to hand over to Magda, who's Director of Construct Innovate, and she's going to talk about the transition pathway for construction. So over to you, Magda.
Thanks very much, Jamie. Welcome, everyone. As Jamie mentioned, I'm Magda Hajdukiewicz, and together with Jamie, I'm a co-director of Construct Innovate, and I'm going to present today the transition pathway for construction, starting from the kind of at the EU level, and then referring back into the Irish construction built environment ecosystem. So construction is the second largest industrial ecosystem in the European Union in economic terms. Just after retail, it employs around 25 million people, brings almost 10% of value added to EU economy. So apart from creating new jobs and driving economic growth, the construction sector provides solutions for social, climate, and energy challenges. And the sector needs to improve environmental sustainability. Our building stock is aging, the renovation rates are still low. So in order to reduce the emissions in the sector, it must promote energy efficiency, reuse and recycling of primary materials, and also accelerate those renovations. The construction sector is complex due to its supply chains. So construction is one of the most resource-intensive sectors. It is largely dependent on other, also mostly energy-intensive sectors for materials like steel, glass, aluminium, etc., for chemical products, for clay products. And finally, workforce availability and skills in the sector are a challenge. So construction is labor-intensive and currently lacking in skilled labor due to aging workers retiring, and then challenges in attracting younger workers. The challenges faced by the Irish construction sector align with those at the EU level. They need to be addressed so that the sector can improve its efficiency and find the required building capacity to deliver on the demands such as those of the National Development Plan. The Irish construction industry operates on a cyclical nature where the value of output in the industry is fluctuating in the timeline. So it fluctuated between over 20% of GDP in 2006 to just over 5% of GDP in 2012. And in 2012, it was slightly higher at almost 7% of the GDP. The second challenge is that the sector is fragmented, with almost 93% of construction companies employing under 6 people. So efficiency and resources can be challenging when companies are small or micro companies. And then finally, construction industry has low levels of productivity. In Ireland, productivity in the construction sector is significantly below many other Western European countries, and it is also lower than in other sectors, industrial sectors. Between the end of 2019 and the second quarter of 2024, the average labour productivity in the Irish economy increased by 6% across the country, but for construction, there was a 29% drop in labour productivity. So this productivity or low productivity remains a challenge for the Irish construction. There are 14 industrial ecosystems identified by the EU in their industrial strategy, and construction is one of them. Those ecosystems are transitioning due to the challenges we had with COVID-19 pandemic, Russian invasion on Ukraine, and the climate emergency. Construction is one of those ecosystems, and it needs to undergo a rapid digital transformation and also embrace the circular economy principles. And the EU recognizes that need for a swift green and digital transition, as it showed in their industrial strategy, which was updated in May 2021. And as part of the strategy, EU is working together with the member states and with industry stakeholders and developing transition pathways to identify the actions that are needed in different sectors that may give a better understanding of the challenges and opportunities that are faced by those sectors. And for the construction, there are several tasks that it needs to focus on. So it needs to deliver building renovations faster than ever before. It needs to install renewable energy generation and manage those systems to help Europe use energy sustainably. It must continually provide monitoring, maintenance services, repair to the critical infrastructure. It has to make buildings safer, more accessible for people. It has to enable processes through public authorities that are moving from paper-based to fully digital procedures. So in general, construction must play its part in the effort to reach climate neutrality by 2050 and also other environmental goals. It needs to prevent, reduce, reuse, recycle waste, increase the use of secondary raw materials, and by doing so, decrease the greenhouse gas emissions. And finally, it may help remove carbon dioxide from the atmosphere also by storing it. So EU has this target of climate neutrality by 2050. And in recent years, different initiatives were launched that impact construction and the built environment. And those include the renovation wave, the proposed emission trading system for buildings and road transport, the new European Bauhaus, the climate adaptation strategy, and proposals also to revise some of the key legislation, such as construction products regulation and the Energy Performance of Buildings Directive. And Ireland has the Climate Action Plan that sets a course for Ireland's targets to halve emissions by 2030 and reach net zero no later than 2025, so aligned with the EU targets. So many targets exist on how the built environment should transform in the future, but far fewer indicators exist on how the construction ecosystem should evolve to deliver on those objectives. And that's where the transition pathway for construction ecosystem comes in. The development of a construction transition pathway started with the European Commission working with the Industrial Forum to develop a blueprint for industrial ecosystems, and that includes construction. And at the end of 2021, the Commission staff working document was published, which described the main challenges and opportunities for the construction ecosystem in Europe. Over 100 organizations participated in open consultation. And around the same time in Ireland, the Ernst & Young report was published. Some of you might know it, a detailed description of needs of the Irish construction built environment sector. And shortly after that, Construct Innovate was established as the first technology centre in Ireland for construction-related research. So following that consultation at the EU level, after the publication of the staff working document, additional meetings and consultation sessions were organised, and all input that was received in this process resulted in a policy report, the transition pathway for construction, that was published in March 2023. This transition pathway includes 6 building blocks, such as competitiveness, skills and talent, enabling framework, research and innovation technology, finance, and safe and fair built environment. And all those blocks must be considered from the perspective of 3 cross-cutting themes of green transition, which is the environmental sustainability and climate neutrality, digital transition, and move towards greater resilience. Each of those building blocks has its own challenges and opportunities, which are well described in the report that is available on the European Commission website. But here I just want to flag a few actions for each of those building blocks that may be relevant to Construct Innovate members and mainly to industry. So competitiveness, this building block is about assessing how construction is performing in relation to other industrial ecosystems and with third countries. It explores the dynamics of small, medium enterprises and startup community, all who are contributing to the twin transition. So twin, when we're talking about twin transition, we mean green and digital transition and also resilience. The recommended actions that I picked here, and there is a total of 14 of them under this competitiveness block. So the first one is investing in technologies that increase efficiency, and this relates to modern methods of construction, as shown in many previous presentations in this webinar series. Another actions relate to increasing the number of startups, improving diversity, and supporting local materials and products, and finally supporting international standardization. And that's one of the main challenges of the MMC sector, as mentioned before by our members. The world of work is changing, and that is happening because of the technology, demographic, and climate change, and also the different geopolitical developments. Automation replaces some labor-intensive tasks. The population is aging, workers migrate, and the industry must reduce its environmental impact. So the talent pool of the construction ecosystem is shrinking, with those aging workers retiring, young people reluctant to consider construction as their career choice. But at the same time, there is a need for upskilling the current labor workforce, and it is extremely important, and needs to focus on investing in lifelong learning, in digital working practices, in better working conditions, social protection, healthier and safer working environments, and in general, better promotion of career opportunities in the construction sector. And here, the IGBC have done very good work on the national upskilling roadmap for the built environment, which is freely available on their website. The construction sector needs an enabling framework to be resilient, competitive, innovative, and to achieve that green and digital transition. The enabling framework refers to the regulatory and policy framework, but it is also what is also necessary for it is the infrastructure, and that means the digital and also the physical infrastructure. There are a total of 37 actions for both the industry, member states, and EU under this block, building block. Many of those are relating to prioritizing renovations and supporting circular economy, also through digital construction product information. And the work of the Irish Green Building Council on implementing environmental product declarations in Ireland is highly relevant here as well. The construction stakeholders, during the process of developing this transition pathway, the construction stakeholders voiced barriers to the uptake of research and innovation solutions. The three main barriers were high number of SMEs and the fragmentation of the ecosystem, which I mentioned before. The second one was that research and innovation are not addressing the needs of the ecosystem. And the third one was regulatory barriers. There are also other barriers that were mentioned, such as culture aversive to change, lack of awareness, lack of demand to drive innovation among companies, lack of skills to implement innovation, and in general, the cost of implementing innovative technologies, which can be specifically challenging for those micro or small companies. So to address the needs of the sector in 2020, the Construction Sector Group in Ireland proposed 7 actions to improve the landscape in the Irish construction and the built environment. And one of those actions was the creation of the Construction Technology Centre, which is Construct Innovate now. The micro enterprises comprise 90% of EU construction companies and 93% of the Irish companies. They tend to have limited power for favorable financing deals, and this is due to lower working capital and to higher perceived business risk. It has been shown that in many cases, there's lack of easy to understand and tailored information on funding and financing possibilities. So within the pathway, there are 8 recommended actions, which mainly focus on the member state and EU to take and improve the financing for the construction sector. The transition pathway focuses on supporting the industrial ecosystem of construction, but the built environment that the construction industry delivers is above all a service to society. So construction policies directly affect the lives of people, the availability and the quality of housing, and even their safety, health, and well-being. So the 8 actions listed in this block support a fair, quality, and safe built environment. So here I gave you a snapshot of the actions under the 6 building blocks of transition pathway for construction. All the actions listed can be regrouped. They can be positioned in time to create roadmaps for a green, digital, and resilient construction and built environment ecosystem. And that's what's happening in different member states, kind of following the guidelines from the EU. And that's what's happening in Ireland as well. The transition pathway for construction at the EU level and also in Ireland is driven by that digitization and sustainability. It is done to improve productivity in the sector for the benefit of the society. So as you can see, this aligns very well with the vision and mission of Construct Innovate, where we have an industry-led and industry-focused center that enables research, development, and innovation, collaboration between academia, industry, and policymakers, and ensures sustainability, digital adoption, and resilience of the sector. So with this, I'm going to thank you for your attention.
Brilliant. Thanks, Magda. That's a great overview of what's happening in the EU and the pathways in the EU, but also how that applies to us in Ireland as well, and how we're responding in Ireland to that. So I'm sure there's lots of people with questions for you. So if anyone's any questions, please post them in the Q&A function at the bottom of your screen there. And we'll deal with those questions at the end of our 3 speakers. So without further ado, I'm going to pass over to our second speaker, who's Pat Barry, who's CEO of the Irish Green Building Council. And he's going to cover all the way from urban design to construction materials. So over to you, Pat.
Great, and thanks, Jamie, for the opportunity to talk here. I'm going to give an overview of where we are and where we're going with the construction. Just a brief introduction to the Irish Green Building Council. We're an organisation of 450 collaborating members, and we work on skills, raising awareness through advocacy, and we do operate a number of programmes such as the Home Performance Index, EPD Ireland, and we are one of the research partner organisations, industry research partner organisations with Construct Innovate. You will have seen a couple of these slides before, and I just want to recap on where we are. The built environment is responsible for 37% of our emissions, and that breaks down into 23% from operation of our buildings and 14% embodied. Now, this is relatively old data. That's from 2018. So the embodied carbon proportion is likely to have increased considerably since then. We released a roadmap at the end of 2022, setting out a roadmap for each of the construction sectors, and for architects, engineers, quantity surveyors. There's a roadmap here for every one of you. And one of my colleagues, Lenny, is currently reaching out to all of those different sectors and asking them what they need to act on the roadmap. So I'm going to talk a little bit about how we get those whole life carbon emissions down, because that's a major challenge. Because I think we pointed out under the development plan for the National Development Plan, in a business as usual scenario, if we built a 2020 Housing for All plan, even if we built just 33,000 houses, the way we were building them, we would see an overall increase in carbon emissions, which means that, we have to look at scenarios for reducing carbon emissions. So even if we reduced the carbon intensity per square meter, and met the RII climate targets, which are quite onerous, then we'd see a reduction, but it wouldn't be enough. So how do we get down to, a 50% cut in carbon emissions from the built environment? And it's becoming all the more challenging as we increase our targets to 65,000 houses per annum. But actually, where I would have been quite pessimistic a couple of years ago, so much has happened in the meantime in technology and ideas and new materials. I think there is the potential, because we probably need to be targeting something like a 70% reduction in carbon intensity, but that might just be possible over the next couple of years. And I suppose we have been working through a number of projects and some of the information and data I will be showing you is from 3 of these programs and projects that we have been working on. Of course, the Indicate project, where we created we actually measured 50 buildings, whole life carbon of 50 typologies of buildings, and that was done through Construct Innovate. Rikuji scaled that up, looking at how infrastructure impacts on our carbon emissions, not just the buildings themselves. So the Indicate project created baselines, essentially helped us create a baseline for Irish buildings using a common methodology that we worked on with the University of Galway and through Construct Innovate. And that gave us an indication of what the carbon impact of different types of buildings is currently, and give us an idea of where we need to get to over the next 5 to 6 years. So I'm not going to go through the detailed figures for those benchmarks, but it's probably more instructive to see where most of the carbon emissions and most of the mass of our buildings is in those 50 new buildings. So in those 50 new buildings, 3/4 of the weight of the mass of the buildings is from concrete, with metals and other materials like brick making up the balance. And I suppose why is that important? We're also doing a circularity roadmap at the moment. So we're not just thinking about the carbon emissions, we're also thinking about the actual resource. Where do we find these resources, and can we optimize resources like concrete and sand, all of which we assume are in plentiful supply, but they do have considerable impacts to extract, not least of being biodiversity. And when we look at this from the carbon emissions of these 50 buildings, we see that it's concrete and cement is still the largest at 41%, with steel being 36%. And surprisingly, insulation has quite a significant impact when you look at it. It's quite a light material. You don't even see it on the mass diagram there, but it's a significant impact in carbon emissions. So how do we get down to, we're targeting something like a 70% reduction in carbon intensity. How would we go about, or even a 50% reduction in carbon intensity from all of what we are going to build over the coming years? And again, you'll see the idea of a pyramid. It really starts with sufficiency. How can we be clever by building less? How can we find ways of intensifying the buildings that we already have, so that we don't have to build as much? Then the next step in the pyramid is optimization. How can we use less materials? Can we optimize the structure? And I know the Institute for Structural Engineers in the UK has done fantastic work there on looking at, I don't know if you've seen the Build Opt project there, where the UK government funded a project looking at how you can optimize the actual structure itself and the layout of the columns and the bracing. But there's also other measures that we can use through 3D printing that can optimize the quantity of material used. And then finally, the lowest part of the triangle is the materials you use themselves are low carbon. So one of the, I suppose, low-hanging fruits starts with the infrastructure, and we haven't really started to think about that because we've been looking at the buildings. So even if you're looking at the infrastructure, how you lay out developments, is there an optimum way that you can lay out the roads? So that not all of the roads need to be heavy vehicle use, say in a housing estate, and could we optimize some of the roads and pathways for lighter vehicles like electric bicycles? Can we optimize car parking and reduce the quantum of materials going into urban development? Again, this project carried out through Construct Innovate, Viable Homes, looked at, what's the difference in infrastructure according to different typologies. And you can see the lower the density, the greater the ratio of infrastructure to the actual buildings themselves. Then it decreases right up to apartment blocks. And it's interesting talking with developers that actually the greatest cost in lower density development tends to be the infrastructure now rather than the homes, because they've optimized the actual units themselves, but they don't have as much control in optimizing the actual infrastructure that's required by the standards. So, I mean, there's obvious simple ways we can change the typologies. Rather than having lots of detached houses and semi-detached houses, we can put them together. That eliminates walls. It reduces foundations. It reduces the length of the pipes and footpaths that you need because you're pushing the houses closer together. You don't need as much infrastructure. You can look at the car parking, say, perhaps moving the car parking slightly away from the houses. You can group them. Then maybe you don't need the same level of road infrastructure. So there's huge low-hanging fruit there if we look at the layouts of developments. a very obvious one. And a lot of this work was done by Philip Comerford and the team in UCD with Oliver Canaan. They did an immense amount of work at looking at every manhole. They downloaded Ishka Aaron's standard manholes and calculated out, what's the impact of a manhole? What's the impact of the road build-ups that we typically put into per square meter in a housing estate? So they calculated all that out. And this is just one example I give you of the way we put in infrastructure. It's different for houses because we put in a last manhole for every single house. With an apartment block, it might be just one manhole. And when you think about that, that's 1.2 tons of carbon per manhole. So there's lots of things that we can optimize. And I can talk about what the impact of this, but what could this look like? Well, this is an example that's already under construction in Falleby in Copenhagen, where they have it's built on a municipal dump. It's built on landfill, and it is close to a metro station. They've backgrounded all of the car parking. They've hidden away all the car parking in an underground in a multi-story car park at the entrance, and they've cut down the amount of infrastructure to the minimum. They've used swales instead of attenuation tanks. Actually, on that study from Construct Innovate, the attenuation tank accounted for 2.4% of the entire carbon emissions, embodied carbon emissions of the entire development. But they're using nature. So they're bringing biodiversity right through the scheme. The only roads through it are narrow cycle tracks, minimum of vehicle access needed for fire and obviously other utilities. But it's an example of where we might be going, and it's clearly a more beautiful environment to live in. And just remember, this is 160 units per hectare. This isn't low density. Our typical densities are 35 units per hectare. This is 165. So it's possible to do high density, biodiverse. And of course, it's all built out of timber. It's under construction. It's three-dimensional, modular, low carbon construction up to 5 and 6 stories. But it's not just timber. There's ways that we can optimize concrete, and this is an example from ETZ, the University of Zurich, who are building this demonstrator to show all of the benefits of combining digital parametric design, where you're optimizing the structure to actually minimize, absolutely bring to a minimum the amount of concrete. So, for example, this is a 78 square meter slab. The total weight of it is 15 tons. It's got a 4.1 cantilever. So it's got it's 1/3 of the mass of a typical concrete slab. So when you think about that, if you combine the fact that you can now use clinker substitutes that can replace up to 70% of the clinker, combine that with a 70% optimization. If my maths is correct, and correct me if I'm wrong, that means there's a 91% reduction in carbon intensity in building that. If you combine those, you're combining digital, you're combining low carbon cement and concrete techniques, and you're combining parametric design. And you're getting very interesting shapes. Now, this is a little bit extreme, but we don't have to go that far. We can apply it to ordinary buildings too. But of course, we also, we've maxed out optimization in the last slide, but then we have new options that are coming through. We're not really yet, we're not really realizing the potential to use biomaterials in Ireland, and we have plenty of agriculture. We can offer farmers the potential to diversify on their farms and create new agri-crops. And again, currently the timber and construction steering group are looking at use of timber at height, and this is an example from Stockholm where they have built 5 stories above an existing 2.5-story warehouse. And this is this is combining strategies. You're using what you already have. You're using low carbon materials then to intensify the use of that. So, and then you're using that existing infrastructure that's already there, the roads, the drainage. So this is the optimum way of kind of reducing carbon by multiple strategies combined. Another interesting example from Sweden. This is 3D modular bio-based construction. But again, it's about simplification, simplifying everything down. So they're able to sell these for under 180,000 krona, 55 square meter apartment just on the metro, half an hour from the center of Stockholm. And again, use the use of parametric design, of course, can be combined with new biomaterials. This is a cross laminate. Sorry, this isn't CLT. It's I forgot. It's cross lumber. It's cross ply, where you're using ply in cross ply to achieve very interesting shapes. So the possibilities for construction is an incredibly exciting time if we realize them. And it gives me a lot of hope. Whereas a couple of years ago, I said, this is really difficult. How are we going to make these reductions so quickly? But I do think it is possible if we apply all of these techniques in combination. So thank you very much. I hope I haven't gone over too much time.
Brilliant. Thanks, Pat. No, very efficient in your time. Covered an awful lot there. In there, I suppose, showcasing like the amount of material that's in our building and how much concrete we actually use, but also the impact that the insulation materials have in terms of the embodied carbon, and then broaden out into our infrastructure and our housing estates and so on, and how we could optimize our design to reduce the amount of items that we need, which then it can reduce the amount of carbon. And great to see some of those examples, particularly from Scandinavia, on how we can bring together multiple different strategies to reduce the carbon and take advantage of existing infrastructure in there. So fantastic there. So again, anyone has any questions for Pat, please post them in the Q&A function at the bottom of the screen. And with that, I'm going to hand over to our third speaker, Roy Crielaard, who's a senior structural engineer in Arup, and he's going to focus on some exciting case studies that are projects that he's worked on. So over to you, Roy.
Yeah, thanks, Jamie. Thanks for having me here today. I hope you can all see my slides on the screen now. I've been asked to talk about sustainable and future-proof buildings, and I will focus on 2 case studies of what I like to call hybrid construction, recent projects that we've done and completed in Amsterdam. The first one being this project, which is called Hout. It's one of the tallest hybrid towers in Europe, actually. And it's constructed out of it has a hybrid structure, so it's a concrete and timber structure combined. Let me talk a little bit about how this project came to be. So this was a competition for the municipality of Amsterdam. It's located on the Amstel River, which is a prominent river going through Amsterdam, and it was one of the last sort of available building plots on this river. And the municipality set some rules for the building. It had to have a maximum height of 73 meters and about 14,000 square meters gross floor area. And in order to allow in order to secure, let's say, development of this plot, the municipality set some rules, and they asked teams to come up with a strategy, and you were to be scored on these criteria. So the design of the building was about 40% of the points. Sustainability, the approach to sustainability of the building was about 30% of the points, and then the associated bid for the land, let's say, and the rights to develop on this plot were another 30% points. We teamed up with Lingotto, who is a Dutch developer, and Team V Architects, which is one of our architecture friends in Amsterdam. And as Arup, we supplied many of the engineering services on the project. And as a team, we felt that the key to winning this project was to come up with a structure that used as much timber as possible. This was back in 2016. Timber was very much talked about in the Netherlands, but the largest building constructed at that time was about 6 stories tall. And we wanted to really make a statement in terms of applying this material in construction. So the idea of our team was to use as much timber as sensible, whilst not compromising on the architecture and the views of the buildings. These were going to be very high-end apartments, so we wanted to have views all around the building. Have all the apartments have excellent views, so we didn't want to have any structure on the outside of the building, but very much centrally located, and also work within the constraints of the site, which had quite an awkward sort of triangular shape. There was a large sort of segment of cables under a part of the building, which was a constraint as well, and we really wanted to work with those constraints. So in the end, we came up with a design that you see here, which was one of the images that was submitted during the competition, where the use of the timber didn't really impact the design much. So we really had clear views all around the building and a very strong architectural expression. So why didn't we do this before? Why was this our first project to have a 70-meter tall tower in timber? Well, first of all, we've seen the rise of mass timber products, which are products that have a much increased properties compared to traditional sawn timber products. And these really allowed us, these engineered timber products really allowed us to use timber at this scale. Furthermore, as you are probably well aware, the modern ways of fabrication have really helped us to realize these kind of projects. For example, with CNC machines, you can really have a high degree of precision and apply mass customization to the elements, the structural elements required for these projects, and apply that in a prefabricated manner where floors and walls and columns, etc., arrive on site and can be installed right away. And finally, one of the enablers for this project was new connection technology. There's been a real increase in the technology of timber connectors, with higher and higher capacities being possible, really tight tolerances, and yeah, this is constantly evolving and really helps us with applying timber to this scale. So for the design of Hout, we applied a hybrid structure, and the reason for that was that we initially pushed for as much timber as possible, but in the end we settled for CLT walls, a concrete core, and timber concrete composite floor. So that's it's a timber slab with a concrete topping that really helps in the structural performance. So why did we end up with this system? Well, initially we really pushed for a full timber design. This is what was used in the competition stage as well. But we found out that if you stack all these structural elements to this height, the fact that timber is a timber structure is made out of all these individual panels with all these joints, and they all have connections in between them. All these connections have a bit of slip in them. They have a bit of give, and that actually reduces the stiffness of the whole quite significantly. So we investigated a couple of options where, for example, we used steel strips and ties to stiffen up that those timber walls, maybe pre-stress it to avoid those deflections. But in the end, we found that we had to add so much steel that it basically offset all the carbon and the environmental gains that we had by applying the timber. So instead, we opted for a very small and compact concrete core, which also helped us, for example, with acoustics. Put all the vertical transportation in there, all the bits that vibrate, and well, it's quite nice to have that compact in that central core. But that core is supported by a number of CLT walls that sit next to it, and that support the structural system, especially in sort of torsional modes of the building because of the asymmetric position of the core. We use the CLT walls for that. So in the end, sort of this hybrid solution where with concrete applied to sensible locations reduce the overall environmental impact of the plan. So, well, we had a number of design challenges during the development of the building. One of them was the differential settlements of the building. You can imagine that if you use concrete elements next to timber elements, there's going to be differences in settlements due to the creep and shrinkage of the timber and the differences in loading. So this was actually a big concern for the contractor, but also for the architect who worried about, finishing being sort of delaminating from the walls and such. So we actually did. We performed quite a detailed analysis of this in time, where we looked at different scenarios, applied the loadings at the right times to really understand the differential settlements and the way they evolved in time. And eventually we were able to much more accurately estimate this differential settlements to be about 20 millimeters instead of our initial guess of an initial estimate of about 50. So that made it much more manageable. And we also introduced some connection details that would be able to take any differential settlements and sort of distribute them across the floor, which resulted in much smaller rotation. So that was solved in quite an elegant way. Furthermore, for these types of buildings with timber floors, vibrations, footfall-induced vibrations are a big concern, especially for apartments like this where they are quite high end, so the requirements are quite tight. Which was one of the reasons why we opted for a composite slab, where there's actually a CLT soffit, which is then with shear connectors connected to a much thinner concrete layer on top, and they work compositely, so it tremendously increases the strength and the stiffness of the floor elements, but it also adds a bit of extra mass, which is really beneficial for your vibrations, but also, for example, wind-induced vibrations for the complete tower. That small layer of additional mass really helped us in that structural performance. It also really helped for acoustics, which is another issue that you need to tackle with these timber buildings. So timber has a much lower mass, which means that both direct sound transfer from one apartment to the other, but also the flanking noise through ceilings and through floors becomes an issue. And again, we use that layer of concrete, but also a decoupling at the detail to avoid that as much as possible. And in that way, we were able to avoid drop ceilings in most locations altogether. And then finally, the fire safety of the building was obviously a concern, which is a whole presentation in itself, I would say. I think the key message here is that timber really behaves much differently from other construction materials, more traditional materials such as concrete and steel, which also means that we had to do we had to develop our understanding of how timber buildings behave in a fire situation. And in the end, for this building, a sort of total fire engineering approach was chosen, where we tried to understand the fire dynamics much better and made really informed decisions on avoiding, for example, delamination of the CLT by choosing the right glue, applying a sprinkler, as well as other passive measures to achieve a similar level of safety that is typically intended by the building codes as applied to traditional materials. And this, of course, all comes together in the connection details for buildings such as this. So you can see sort of the development of those details of a typical sort of apartment to apartment separation detail, which really is a key detail to get right at an early stage. And I would say that sort of a key challenge here was developing an economical as well as a technical solution that would feature these flexible floor plans, have that transparent facade that I showed earlier, and have visible structural ceilings, timber ceilings. And especially with 21 levels, it also needed to be easily constructed and satisfy all the requirements for structures, fire, acoustics, and so on. So I think the solution with a custom designed precast timber concrete hybrid panel applied in sort of this platform construction really helped in that sense. And that was really developed iteratively in an integral design approach together with the client, the architect, as well as the timber and concrete subcontractors. So some pictures from construction, which you can see here. You see the concrete core going up and the timber walls, shear walls around it. Inside, you can really see that there actually is a lot of timber in the building. You can see the timber soffits, the walls, which would later be covered. The ceiling would still be visible. MEP integration also makes for a very interesting challenge in timber buildings. On the one hand, it really allows for ease of installation, but on the other hand, especially penetrations through beams are much more of a challenge. So that allowed for a lot of coordination. But in the end, I think the end result looks really good, and it remains very true to the original intent of the competition. And the project actually won some awards. It's won a BREEAM award, but also the Structural Awards 2023. It won the overall structural award as well. So I think that's a nice recognition of the work done on this project. Then quickly, there's a second project I wanna highlight briefly, which is a project that has more recently been delivered, which is the office building for DPG Media, a large Dutch media firm. And again, this is a hybrid structure where timber is applied where it really makes sense, but it also features concrete again in the cores and in the timber concrete floors, in a sense that it makes sense for the design. So this building is located again in Amsterdam, just outside of the sort of the city ring, and it's one of the largest hybrid timber concrete hybrid offices in Europe. You can see the design here of sort of three blocks in a staggered approach on a shared plinth and quite a deep parking basement underneath. We as Arup we joined this team only after sketch design. Which means that already a sort of design iteration was done and the building was envisioned initially as a concrete building, but there was a wish to apply timber. So what we did first was we rationalized the grids as much as possible, got rid of all the transfer structures as much as possible in the building, but we in the end we were left with quite a long spans, 8.1 meters, which is quite a challenge for timber. So what we did is we actually developed three options. We developed a concrete scheme, a hybrid scheme with concrete cores and timber concrete composite floors, and a full timber scheme. And together with a cost consultant, we looked at the additional cost compared to the concrete scheme of these options. And we calculated that there was about a 3 to 5% increase for the hybrid option and about 10% increase for the full timber option. And our client, DPG Media, they made a very conscious decision to go for the hybrid option, where they felt like they got a significant increase in sustainability, in performance of the building, for quite a small increase in cost. And furthermore, with this hybrid option, we were able to shorten construction period for about 5 months. And DPG Media was at the time, they had many offices all through Amsterdam, and a lot of the lease contracts were about to end. So with that 5 month increase, that increased speed to market, they were actually able to save a lot of money on all of their leases. So they made a very conscious decision for the timber hybrid option. And of course, there were other knock-on benefits. We could reduce the foundations quite significantly, the structure in the basement, so that all helped as well. And we actually found that now that the building is realized, that sort of 3% initial cost that they paid, when you look at the value of the building now, it's actually worth much more, both from a monetary point of view, but also the users, all of their employees, they are extremely happy with the building. This building is located outside of sort of the ring of Amsterdam, so they really wanted to make a beautiful building to make all the employees happy, because they were not initially not so keen to move sort of out of the city center to a more slightly more outside location. But now that the building is realized, they really enjoy it actually. So just to wrap it up, some pictures of construction. So you can see the two-story basement being realized here with the concrete structure, the timber columns going up. You can see the concrete core being realized. The timber floors. In this case, it was chosen to have an in situ TCC floor, so the concrete is poured, is cast on site. So you can see the grooves with the dowels here, the reinforcement on top, which is connected into the core, obviously, and then the concrete is poured on top with some propping underneath, again because of the large 8.1 meter spans. So the building has now been finished, and it was actually opened recently by the Dutch king, which is quite exceptional actually, because he usually doesn't open any buildings, only public buildings. And the building also won a couple of awards, so best Dutch office building and best Dutch timber building. So again, that's quite a nice recognition for this timber hybrid building. Yeah, that's it from my side. So yeah, very quickly, a brief overview of two of our recent projects, where we try to achieve a sustainable and future-proof building by means of this hybrid construction.
Brilliant. Thanks for that, Roy. That's fantastic. Two very exciting buildings. Also nice to see the some numbers there in terms of the decision making from the clients that's willing to pay that 3 to 5% initial capital cost up front to go to hybrid concrete timber scheme over concrete, and then that's to actually work out that the value of the building afterwards is probably higher than that additional cost because of going to that scheme. And then if you take into account productivity of your staff on top of that, they probably have gained that initial capital investment well back already fairly quickly.
Exactly. So I think whilst the sustainability argument is quite a well-known one, I would say for timber, now in Amsterdam and in the Netherlands, we as Arup, we try to focus more on two other arguments, which is that speed to market, which is very important, especially as buildings go taller. Cutting off 6 or maybe 12 months of construction time is really significant. And the other argument is that increased value. So we really try to make a business case now of sustainability and of sustainable buildings, where we now have a number of actual case studies where we can demonstrate that it is a slight increase in price upfront, but you earn it back 3 or 4 times in value and also in mitigating the building being a stranded asset into the future. Yeah.
Yeah, very good. And I suppose there's a back of the envelope calculation that kind of shows that if you can increase 1% productivity of your staff within a building, you can actually pay for the capital cost of that building up front if you look at the whole life of the building itself. And
Yeah.
that kind of rounding number works for a lot of especially the bigger buildings and that. So
Yeah.
it is worth the client's while if they look at the long-term view of doing really, really high quality buildings.
Yeah.
And what people are looking for is high quality, really good environments to work in, both that we're happy, we're satisfied, we've clean air and so on in there, but also then the resale value, or the as you say, not to have a stranded asset at the end of it, because we can see what investors are looking for down the line.
Yeah.
They want values that are either easy to retrofit or easy to change around the use of, and that they're low energy buildings, or can be at least retrofitted to be low energy buildings fairly easily going forward.